Hello everyone. Hello everyone. Am I audible? So today we are going to learn OS. So let me check that if I am live or not and whether the screen is visible or not. Yes, the screen is visible and I'm audible also. Okay. So yesterday we have completed half of OS. Okay. In that we have seen the introduction part. We have seen the types of OS. Okay. Various types of OS. We have seen program, process. Okay. So little bit we started with process management yesterday. Okay, in yesterday's class we also have seen fork system call, we have seen transaction state diagram. So in today's lecture we will be starting with scheduling formulas. Okay, so let's get started with scheduling formulas. Scheduling formulas. So here is ATI is equals to arrival time. Okay, CTI is equals to completion time. Xi is equals to burst time. Yi is equals to input output burst time. Okay, this is just burst time, this is input output burst time. The formula is TAT of I is equals to CTI of I minus arrival time of I. WTI is equals to TAT of I minus XI plus YI. Okay, and the schedule length of L is equals to max CTI minus min ATI. Okay, and throughput is equals to is L, okay, N by L. So this throughput means so throughput means N by L. Okay, so let's see now scheduling algorithm. So there are various types of scheduling algorithm. So please solve one question on all of this scheduling algorithm. FCFS, SJF, SRTF, LRTF, after that HRRN, priority, round robin, multi-level queue, multi-level feedback, all of this just note. Okay, and the response ratio, if you want to calculate response ratio, then it is WT plus BT by bt is equals to wt bt. Okay. After that, performance of SJF. So now if we talk about performance of SJF, then max throughput. It will give you max throughput. Second is average waiting time is less. Okay. Third is starvation to longer process. After that, fourth is non-implementable. It's non-implementable because early on we do not know the less burst time. Okay, so that is why. After that, let's see exponential averaging. Okay, so before discussing that, let's discuss effect of time quantum. Okay, FV is small, then more context switch, more interactive. If very small, then n is 0. Okay, and if quantum time is, so it is if small, the effect of quantum time if quantum time is small, and if quantum time is large, then less context switch, less interactive. If very large, then it acts as FCFS. Okay, then it acts as FCFS. So note this, everyone. And with this, we have completed with our process management. After that, we will see process synchronization. Okay, note this, everyone. Okay, so now let's see process synchronization. So critical section, which is CS. Okay, so part of the program where shared resources are accessed, okay, read or through write. This is called as critical section. After that, race condition. So race condition means the outcome of program depends on sequence of execution. What is preemption? Forcefully stop execution of currently running process. That is called as preemption. And what is non-preemption? Without any force, the process is organically completing itself. Okay, without any pressure, without any force, it itself is completing everything. So that is non-preemption. And preemption means if we are remove if we are removing a process forcefully from a CPU, that is called as preemption. Alright everyone. Now let's see mutual exclusion. So mutual exclusion means no two or more process in the critical section concurrently. Okay. So requirements for so we should know here mutual exclusion, progress and bounded waiting. Okay, so all these three terms should be absolutely clear to you all. Alright, so that is very important, and do solve a question on that to know that you are perfect on these topics or not. After that, let's see synchronization mechanism. Okay. Synchronization mechanism. Okay. The very first is software. Second is hardware. Third is kernel based. Okay. So lock variable. Okay. That is, after that, strict alternation. Third is Peterson's. Okay. Then here the hardware here is TSL, SWAP. After that, Peterson's solution. Okay, is two process solution only. So this is actually a point that Peterson's solution is a two process solution only. So this is a point. Okay, and the hardware is SWAP and TSL. After that, kernel based is semaphore and monitors. Okay, so this point plus deadlock possible because of priority inversion possible or problem, inversion problem. Okay. So notice priority inversion problem may occur when busy wait in synchronization mechanism is used along with preemptive priority scheduling. Okay. So in semaphore we have counting semaphore and binary or mutex semaphore. So let's talk about counting semaphore. Okay. Counting semaphore. So counting semaphore, the first is up and down. These are atomic values. Second is up is always successful. Third is negative value of counting semaphore indicate size of Q if and only if initial value was positive. Okay. After that, let's talk about binary semaphore. Binary semaphore, if there are blocked process in queue, then value must be 0. Value must be 0. Okay. If value is 0, then there may or may not be blocked process. If value equals to 1, then nothing is blocked. Then nothing is blocked. Okay. So first reader writer problem also we will see. So note this, everyone. Okay, everyone. Now let's see the next one. So reader writer. Let's see now reader writer problem. First reader writer problem. Okay. First reader writer problem. So the very first is, if reader are reading, then subsequent readers are also allowed, even if writer are waiting. Even if writer are waiting. So this is reader writer problem. Second is reader writer problem. So this is the second part of this, which is T0 equals to R1, T1 equals to R2, T2 equals to W1, T3 equals to R3. Okay. So this is waits until all queued writes are done. Okay. All queue writes are done. After that it will read. After that, let's see dining philosopher. Dining philosopher. So which is n-1 philosopher, left to right it should happen. After that, one philosopher, right to left. Okay. And if odd philosopher is there, so left to right, and even philosopher is right to left. Alright everyone, any doubt? So please note down this. I'm giving some time, and if you have any doubt you can just ask. So note this everyone, I'm giving a minute time. And if you want a quick revision, you can just watch this video in a little speed up way. Okay. So that in less time, everything will get covered. Now let's see deadlock. So conditions for deadlock. Let's see first that conditions for deadlock. The very first condition is mutual exclusion okay. Second is hold and wait. Third is no preemption. Fourth is circular wait. If any of the condition is happening, then it is the condition for deadlock. Okay. It is the condition for deadlock. Now with a very simple diagram, I will explain how deadlock is happening. See, let's suppose this is RA, resource A, this is resource B, this is process PI, this is process PJ. Now, PI wants resource RB, but PI is holding resource RA. PI is already holding resource of RA, but it is wanting RB. And what is happening? RB is already held by PJ, but it wants RA. It wants RA. And no one is leaving each other. No one is releasing the resource. So this is clearly deadlock condition between PI and PJ. So this is a deadlock. This is a deadlock situation. Okay. Okay everyone. Now we will see how to handle deadlock. So there are three types of handling deadlock. Okay. Okay, so let's see now. Deadlock handling. So the three types are there. First is type 1, second is type 2, third is type 3. Okay, so type 1 is prevention, okay, avoidance, and for here we will learn banker's algorithm. Okay, after that type 2 is yes, we have detected, and after that we will look for its recovery. Okay, and third is ostrich algorithm, where we know that the problem is there, still we will not care, we will hide. So what ostrich does, if some problem is there in front of ostrich, it will put its neck inside, its head inside, okay, thinking that there is no problem because ostrich cannot see now. So that is what ostrich algorithm is. Okay, so it is n k minus 1 plus 1 smaller than r. Okay, so it is give 1 less to each process and still have one left extra to prevent deadlock. To prevent deadlock. And there is one table also for this. Okay. Okay, like this. And here is safe. Here is unsafe. Safe sequence, unsafe sequence, this you should know. And here the possibility of deadlock is there in unsafe. In safe sequence, we will never face deadlock. But in unsafe, we will definitely will face deadlock. So what are this sequence, what are algorithms and all this you can study very properly. Okay, so if the question will come, you should be okay with all this type of, okay, all these types. Please read this properly and do let me know if you have any doubt. Okay, so done everyone. Now let's see memory management. Okay, so let's see memory management functions. Function, okay, allocation of memory. Second is protection. Third is free space management. Fourth is deallocation. Okay, so this is what function is. Okay, now goals. So let's see what are the goals. Very first is effective utilization. Effective utilization. Second is effective utilization is minimum fragmentation. Second is manage execution of large program in smaller memory, which is virtual memory. Okay, which is virtual memory. So note this everyone. Okay, so let's see memory allocation. Memory allocation. So memory allocation methods. Contiguous, non contiguous, contiguous, non contiguous. So the very first is partitioning. Second is overlays. Okay, like this. Non contiguous is paging, segmentation, and VM. Okay, so let's see now the difference between paging versus segmentation. Paging versus segmentation. So paging versus segmentation. So now this is IF, EF. Okay, so paging and segmentation. So it is, this is possible, this is not possible, this is not possible, this is possible. After that we will study fixed partitioning and variable partitioning. Okay, non-contiguous allocation, we will see paging as well, and segmentation. And after that, demand paging, page replacement algorithms, thrashing, and the reasons for this. Okay, so let's see now fixed partitioning. Fixed partitioning, the very first is number of partitions. Number of partitions are fixed, but not size of partition. Second is partition. Partition partition okay, startup. Okay, first we have to start up, and after then we have to get deleted, then reboot will happen. Third is best fit, BF. Okay, best fit works best for this. Works best for this. All right. After that, first partition is first process. Second is internal fragmentation. Then degree of multiprogramming is directly proportional to number of partitions. Max size is directly proportional to largest partition. Okay, so note this everyone. Okay, so let's see now variable partitioning. Okay, variable partitioning. First is create partition whenever is required, whenever it is required. Second is partition table maintained in OS area of memory. Third is worst fit, which is WF, give the best results. Gives the best results, like number of IF like no if but ef is there. Degree of multiprogramming is directly proportional to not limited. Max size is directly proportional to largest free whole size. Okay, so note this everyone. Let's now focus on non-contiguous allocation. Okay. Non-contiguous allocation. So here is logical address, physical address comes into the picture. So be very good with this concept. Okay. After that, paging is very important because every time 1 mark or 2 mark question definitely comes from this. So number of pages is equals to physical address, logical address. Okay. After that, p is equals to log base 2n, d is equals to log 2 ps page size. So this is physical address size by page size, which is n. This n is number of pages, d is offset. Okay. la is logical address, which is frame and which is not p means pages and d means offset. Okay. And page entry is denoted as e. Okay. So number of frames, pas by ps, which is m, frame is equals to log 2 m. After that, physical address is equals to frame and offset bit. And page table size is equals to number of pages into e, which is page entry. Okay. So like this. And if page entry is not there, so what are you going to add? Frame you are going to add. Okay. So note this everyone. Okay, so let's see now the formula for this. So effective main memory access time, be very good with the formula when the TLB is present and when it is not present. Okay, what is segmentation? So segmentation is divided, logical address is divided into different size, which is segments, and any segment can be loaded in any free hole, and segmentation preserves the physical view of the memory, and TLB can also be used for segmentation. Okay, and the diagram also, be good with the diagram, okay, of whatever is provided. Let's see now demand paging. Demand paging. So demand paging is if page to be replaced is modified to disk access is required. First to write back and first to read new. Okay, otherwise only one disk access is required. And effective main memory access time of demand paging is P into plus P minus 1 minus P into main memory. Okay, after that page replacement algorithms are also there, which is FIFO, optimal, LRU, MFU, MRU, etc. So note this, everyone. Okay, so let's see now the next thing, which is thrashing. Okay, but let's note few points on this. FIFO suffers from B ladies anomaly, optimal replacement gives the list. Okay, we will also treat thrashing. It implies very high or excessive paging activity. Okay, paging activity. So let's say if PS is less, so reference string is there, is high, so page fault is high. So this is called as thrashing. Frames are low, page fault is high, thrashing will be high. Okay, And the reason is lack of frames, okay, and replacement algorithm. So please note this, everyone, and do let me know if you are not getting any of the point or if you have any doubt. After that, the last topic which is left is file system. Okay, and focus on the things whichever I have said, like algorithms. Do focus on that. Page replacement policy. Try at least one problem on all of this. Okay. So it is only we have just three things, okay, in file system, which you should understand. First is contiguous allocation. Second is linked allocation. Third is indexed allocation. Indexed allocation. So you should also see these all things as well. Okay, I'll give you one question. So answer which is the correct. Okay. Which of the following is measure? So this is a part of revision, but taking that revision in form of question. Okay, so to make you note that point, so which of the following is a major part of time taken when accessing data on the disk? A is settle time, B is rotational latency, C is seek time, D is waiting time. So answer this, everyone. Okay, so which is correct? So it is seek time, because seek time is taken by the head to travel to the track of the disk where the data to be accessed is stored. Okay, where data to be accessed is stored. And solve the questions of input output also. As I said, and cylinder problems also. Just take 1 to 2 problems and try to solve them. So here everyone, we have completed with the OS. Tomorrow we are going to study COA. We are going to have a complete practice on COA. So in today's class, do you all have any doubt? If yes, then you can ask me in the comment box, and if you are available live, so you can ask me right now itself. So tomorrow, from tomorrow, COA we will start. I think COA will take 2 days because it's a long chapter. Okay, long subject. Okay, so see you all in the next class.